Fibers were light and cooperative, all on one thread, taking turns. Sometimes you want the opposite, real parallelism, using every core in your machine at the same time. For that, Kaappi has genuine operating system threads, following the SRFI-18 standard. Import SRFI-18. Make thread wraps a function. Thread start launches it on a real OS thread, and thread join waits for it to finish and hands you back its result. 6 times 7, computed on another thread, 42. Processor count tells you how many cores you've got to work with. 12 on this machine. Start a thread per core, and they run genuinely at the same time, not just taking turns the way fibers do. Here's the big difference from fibers. Each thread gets its own memory. The thread can see nums, but it works on a private copy. It computes 10, 20, 30, while the original list back home is still 1, 2, 3, completely untouched. Threads share nothing by default. That copying is the whole safety model. You hand work in when you start the thread, and you get the answer out when you join it, both deep copied across the boundary. No shared variables to corrupt, no locks to forget. It's message passing, where the message is simply the return value. Fibers are the ones that share a heap and pass values over channels. Let's prove it's really parallel. 3 threads, each doing a slice of work. Here, a 1/10 of a second sleep standing in for something heavy. Then we collect all 3 results. If they ran one after another, that's 3/10 of a second. Time it. It comes back in about 1/10. They ran side by side. That's the payoff. Real wall clock speedup on multi-core work. So which do you reach for? Fibers when you're doing many things that mostly wait. I/O, connections, on one shared heap. Working even in the sandbox and the browser. Threads when you've got heavy computation to spread across cores, each one isolated with its own memory. Waiting work, fibers. Crunching work, threads. Real threads give you real parallelism. 1 VM each, isolated by design, results copied back when you join. Between fibers and threads, Kaappi covers both kinds of concurrency without a single runtime lock. Next time, we start reaching outside the program, files, the shell, and the world. Thanks for watching. Subscribe for more Kaappi.